Hey geometry students, welcome to our lesson on circumference and area. This is something that you probably saw a little bit in pre-algebra and algebra 1, but we're just going to brush up and expand on what you've learned about before. So the first thing is called the circumference of a circle. Now the circumference of a circle is a fancy word that means essentially the same thing as perimeter, right? It's all the way around the shape. It's different from perimeter because perimeter we normally add up all the different sides, but for a circle you have one continuous curved edge. So that's why we have a different vocabulary word. Now the the circumference of a circle formula is circumference is equal to 2 times pi times the radius of a circle. Now, just to review some of these ideas, pi is about 3.14. And the question is, where does this come from? So the interesting thing is the circumference, which is all the way around the circle. If you look at it for every single circle, no matter how big or how small, and you have that radius, the circumference is always the radius times 2 times 3.14. So this is a true fact. If you were to measure a bunch of different circles with string and compare that measurement to 2 times pi times the radius, you would get the same thing every time. That is a true formula. So you can test it if you are curious. Another way to write the formula as well is diameter times pi. Remember, radius, I'm going to put a little note, is halfway across the circle. Diameter is all the way across the circle. So 2 radius is the same thing as diameter, right? And we're going to use this, and we're just going to practice a couple of them right below. So practice finding the circumference of the circle. Feel free to pause the video and try them on your own, and then unpause when you're ready to check them. For the first one, I'm going to use the top formula, 2 times pi times radius. So that's going to be 2 times pi times 11, right? You can either write your answer as 22 pi. Notice that's just doing the 2 times 11. Okay. If you would prefer, you can also, I'm going to pull up my calculator for a quick moment. You can also get a decimal approximation as well for your final answer. So if I go into my calculator, and if I do 22 times my pi button, I click the yellow button, and then this caret button gets me the pi. It's about 69.12. So I'll put approximately 69.12 if I rounded 2 decimal places, right? I'm rounding the second one up because the 5 follows. And you can write your answer either way. Both of these are correct answers. So you can leave it in terms of pi or round it as a decimal. For the second one, I want to show you with that second option for the formula, that circumference is the diameter times pi. Notice this measurement that they're giving us here, that 17, that's all the way across, that's your diameter. So for this one, rather than doubling the radius, right, the previous one, the 2 11s make all the way across, we can just do 17 times pi. So our answer is 17 pi meters squared. If you would like a decimal approximation, you can do that. 17 pi, it's about 53.41. Right, notice right there I am rounding. So 53.407, the 0 is going to be rounded up to a 1 because the 7 is 5 or bigger if I'm doing 2 decimal places. So there are 2 answer options below. Okay, so far we've reviewed what the circumference formula is. We've reviewed that radius is halfway across the circle and diameter is all the way across the circle. Okay, the circumference formula is something that will always be provided, but you want to understand where it comes from and why we can use it. And the next formula we're going to look at is for the area of a circle. This formula actually relies heavily on the circumference idea. So what we see here, I'm going to kind of focus in on the left picture. We've got a rainbow wheel. Now, the circumference right? That's all the way around. So that's my circumference, all the way around that circle. What's interesting here, if you look, that distance side to side, that's not all the way around the circle. Notice we're only doing 1, 2, 3, 4 of them. So this right here is half of the circumference. So if I take my circumference as 2 times pi times the radius, if I divide that by 2, those 2's cancel. That's where they're getting this distance is pi times the radius. Okay, so that's where that's coming from. So the base of this shape, which looks like a parallelogram, right, is pi times the radius. And then that second distance they're showing you is the radius. From the center of the circle to the edge of the circle, that's your radius. So that's where they're getting this height, or not quite height of the parallelogram, right? It's that other side of the parallelogram, excuse me. The height would have to be perpendicular to the base, making a right angle. Now it's kind of looking like a parallelogram. If we go to the second picture on the right side, notice we have far more sectors or pieces of the circle. And then as we increase, right, as we have more and more slices, notice the edges are straightening out. So it's starting to look not so much like a parallelogram and more so like a rectangle. And at that point, the area of a rectangle, right, is base times height. So I'm going to put a little note. The more slices, right, the closer you're getting towards a rectangle. And to get the area of a rectangle, we just do base times height. So if I did that, I would say it's pi times radius times radius. Now, a cleaner way to write that is pi times radius squared. Anytime you do a number times itself, you are squaring the number, right? If you had 3 of them, r times r times r, that would be radius cubed. If you had 1, 2, 3, 4, that'd be radius to the 4th power. So that's just our exponent notation, a way to simplify our formula. So area is pi times radius squared, and that's really coming from the idea that if I slice a circle into all those pieces or sectors, when I line them up just so, the more slices or pieces I create, the closer I can arrange it into a rectangle. Okay, so that's where we get our area formula from. You're not responsible to be able to recreate how we get the formula. You're responsible to understand why it works and to use the formula. So for some practice, I've got kind of a core practice, right? I say this first one's core. And then we have kind of like some mixed level where it gets a little bit trickier and it gets a little harder as you go on. So let's just start with this core practice. We've got some circles. Apologies that this one cut off. So we've got some circles here. So what we've got here is 4 different circles with clues. I'm going to kind of split them into distinct 4 problems. Okay, so each of these 4 problems gives you a circle and they give you a clue such as what the radius is, what the diameter is, the circumference, or the area. And the goal is those 4 things, right? You want to figure out all of them for each of these circles. So if I give you the radius for this one, I'll kind of do this one with you. We also want to know what the diameter is. Remember, the diameter is all the way across while the radius is half. So it'll be 6 times 2 or 12 centimeters. Feel free to look back at your previous page if you need a reminder for these vocabulary words. So we've got the first 2, right? We need the circumference, which is 2 times pi times the radius, right? So 2 times pi times the radius of 6, or you could use diameter times pi as well. That'll give you 12 pi centimeters for your circumference. You could do that formula or diameter times pi, remember? And then area is going to be pi times my radius of 6 squared. And 6 times 6 is 36. Rather than write pi 36, most people prefer to put the number in front like a coefficient, like how we would write 36x rather than x36. And then my units for area, rather than just centimeters, are going to be centimeters squared. So this is really just practicing those new vocabulary words and making sure that you guys are comfortable with them. So go ahead and pause and try these next 3 out for practice. Okay, guys, there are those 3 practice problems. Big ideas here, right, is radius is half of diameter, right? Or 2 radiuses make the diameter. So that's why, for instance, for this problem, I had to take the diameter and cut it in half to get the radius. And then notice here, I'm also using that other version of the circumference formula. I'm going to highlight both of those in yellow. Those are 2 different ways of writing it. That's really coming from the fact that 2 radiuses make a diameter. Some other little tidbits here as we're looking is for this problem here. In order to pull something from the area formula, we have to understand that radius squared is 81. So you have to think about what times itself is 81 or square root it to get your radius. And then from there you can plug that in to get your diameter being double that in the circumference. Similar thing here for our circumference formula, you had to recognize that 22 is either diameter, if you're using the diameter times pi formula version, or remember it's 2 times pi times radius as well, that if you wanted the radius, you'd have to cut the 22 in half. Okay, so just walking through some practice problems, making sure you guys are comfortable. On Monday next week, we're gonna do some of these more for practice to make sure you're still feeling good. I would call this one a mixed level problem. We're gonna take our picture and find the area and perimeter of the semicircle if its diameter all the way across is 10. So if you want to label the radius as 5, feel free to. So let's see, our area of the whole circle is pi times radius squared. So that's pi times a radius halfway across of 5 squared. 5 times 5 is 25. I'm going to write the 25 in front like a coefficient, right? 25x, not x25. Same kind of idea here. Remember, centimeters squared if we have area. Now, if I only want half of that circle, right? A semicircle is half of that. I'm going to do the 25, cut it in half, and get 12.5. So my answer is 12.5 pi centimeters squared. We still have got that pi. I'm just cutting in half the number. So half of 25 pi is 12.5 pi. Okay, and then if I want the perimeter all the way around, right? It looks like we've got 10 plus this amount. Remember, this is going to be half of your typical circumference. So your circumference is 2 times pi times your radius. Right, if I did that, it'd be 2 times pi times my radius of 10, or sorry, times my radius of 5, so we get a 10 pi. If I want half, I'm going to do 10 pi cut in 2 is going to be 5 pi. So we only want half of that circumference, right, half of it all the way around. So my perimeter would be 5 pi, and then we have to add that other little piece plus 10. There's not really a way to write that other than 5 pi plus 10 centimeters. At that point, it's going to be kind of messy, so it might be a little bit nicer to do 5 times pi, 5 times pi, and then add 10 to that, because it's a little bit easier to write it just as one number. So I'm going to round to 2 decimal places, so 25.71. centimeters. Notice our units for perimeter, diameter, radius are all just regular units like inches, centimeters. Only for area do we have units square. Okay, so that's our kind of mixed level practice. Here are a couple more mixed level practice. It's going to incorporate area with other shapes. So this might feel a little bit of a stretch now, but we're going to make sure to do some practice like this on Monday. Okay, so go ahead and pause the video and try out number 3. Okay, here is the worked out solution for number 3. Go ahead and double check. And then we're going to also move on to number 4, which is also a shaded area problem. Pause and work it out on your own. Unpause to double check. Okay, so here's the worked out solution. Big circle, take away 4 of the little. You can work it out with fractions and get an exact answer of 55 pi. That's using some fraction manipulation off here on the side, which applies to here. Or you've got a decimal approximation as well. Either is totally fine. Okay, great job, guys. That's it.